Group 4 will be creating a robotic owl to simulate the physiological and scientific concepts utilized by an owl in its search for prey. An owl has asymmetrical ears to help locate the sound origin of its prey. It does this through interoral time difference and interoral level difference in order to perceive the vertical and horizontal location of its prey. Group 4 will replicate this process using a controller, sensors, sound emitters, and a coordinate plane. User 1, a student, would take the owl and station it at one end of the coordinate plane, while User 2 would station the emitters across the coordinate plane without User 1 knowing where the emitters are placed. The time that it takes for sound to leave the emitter and reach the sensors or the owl is used to calculate the probable distance between the owl and the sound emitters or its prey. The whole process is repeated once one ear is lowered to mimic the asymmetry found in most owls. At that point, the vertical and horizontal location of the prey could be calculated.
The system will be running off an Arduino board that will operate the lights, sensors, and motors required to make the game run properly. The game will require a shield that will restrict the first user from seeing the owl as well as the prey. The game will rely on the fact that User 1 is trying to locate the prey the way an owl would. Prey 2 will be placed by a second player, making this more of a cooperative experience. The game will have two modes of operation, one for volume and one for time. The volume mode of operation will use the prey making a constant noise so that the user can find the prey using the servos within the ears. This game will teach the general understanding of how sound is measured through the units of decibels. The time mode of the game will operate under the principle that sound moves at a constant speed and thus will take longer to reach whichever ear is furthest from the prey. Using the same servo mechanism for the first game, the ears will be adjusted left and right as described earlier. This game will demonstrate the relationship between velocity, time, and distance. The shield will contain two simple 4-digit displays, one for each ear that will read either decibels or time depending on mode, and will use an LED indicator to display which mode the game has been placed in. The shield will contain two mechanical levers to raise and lower the ears independently. The mechanical levers have been selected over the electrical to reduce power consumption. The two dials on the shield will allow the user to rotate the ears left and right, as mentioned before. The prey will be a speaker on an adjustable rod that will be placed in either a high or low position. The prey will have a connector that will connect it to the board, allowing the system to know where the prey is and for the prey to get sound.
Our item will be used both in and outside of the academy, and because of this, it needs to be easily transported. Fully disassembled, it needs to fit within a tote that measures 13 by 15 by 19 inches and weigh no more than 35 pounds. This way it can be easily transported by one person. In addition, it needs to survive a fall test of 5 feet to simulate falling off the top of a table. Our product is set up towards elementary school students. We think it's important that they interact with the product and also with each other. Because of this, we set it up so that there are two user inputs. One user will control the location of the speaker, while the other student can control where the owl's ears are pointing. Because of this game style format, it needs to have a quick reset time, under 30 seconds. This enables as many students to go through as possible within the time constraints of the academy. In addition, we think it's important that the students hear as the owls do, so they'll be able to hear the sound emitted by the speaker, as well as seeing the owl's ears locating where the sound is coming from. Lastly, we'd really like the students to be interested in sound source localization and hope that they will leave the academy having a better understanding of how owls find their prey.
This project will teach both a natural science and an applied science to students. Since this project is intended for younger students but can also be used with older students, each subject can be oriented to each age group. The natural science we will be teaching is physiology, while the applied science we will be teaching is math. For the high school students, we will be focusing on geometry, though there is some overlaps in algebra. Now, as mentioned before, the audience that we are trying to educate breaks into two groups. The first one is elementary school students, specifically 3rd to 5th graders. For these grades, math will be used in comparing the calculated distances on the display to tell whether the prey is nearer or farther away. The science curriculum for these grades covers different animals and how they have certain skills to help them survive. This concept will be reinforced through how the position and mobility of owl ears help it to hunt. The second one is high school students, specifically 9th and 10th graders. For these grades, math will be covered by having the students calculate the distance from the prey to the owl. Ninth graders taking algebra will be able to use techniques such as the distance formula, while 10th graders taking geometry will be able to use a combination of techniques like the Pythagorean theorem to calculate the distance. Biology taken by these grades delves into how animals evolved to better adapt to their surroundings, and thus the physiology of those animals.
Our concept of an owl hearing robot is brand new and has never been done before within MEM 435. Through our research, we have found no other robotic owls around that are anatomically correct and accurately portray an owl's hearing abilities and its ability to sense direction based off of the noises. Our group will accurately depict owl ears and the layouts on the owl's head. In our pictures, you can see that there are stereotypical owl ears and the actual owl ears. Owl ears are no more than just holes in the owl's head. In this picture, you can clearly see how the gray spots on the owl's skull depict where its ears are. On the right side of the owl's head is its upper ear. On the left side is its lower ear. This helps the owl determine the location as well as the height of the noises that are incoming. Our group will produce a product that's visually appealing, approachable, and interesting to museum goers.